I want you to remember the problem of the first cell. I kind of brought up some of the cell's organelles, and we talked just briefly a little bit about the cell membrane. I want to go back and look specifically at a couple of the organelles, including the cell membrane, and go a little in depth to some of the things that those organelles do for the cell, and talk about how that could not have just been by chance. And remember, Darwin actually thought that the cell was nothing more than like a Lego, just a building block for life. That's all it was. And in fact, the name cell came about because they thought it was simple, like jail cells or the places where monks lived, just little compartments. That's all they thought cells were. Well, as we have learned more and more and more about the cell, we found out that, oh my goodness, there's so much more complexity than just being a Lego. It's not just a building block of life. It's so much more than that. Each of those organelles had to be designed and were designed with purpose behind them. So what we want to do in this devotional is we really want to look into the cell membrane and look at its parts first. The cell membrane has receptors and enzymes that act like specific junctions for needed substances to be brought into or sent out of the cell. So how could the cell membrane have just happened to pop into existence? It's not just a bunch of molecules ordered in such a way as to form a compartment like they thought it was. There are all sorts of specialized proteins and molecules that must be present and work right for the cell membrane to do what it must do for life to happen. So for the first one we're going to look at is the protein channels. We have talked about what the cell membrane, the molecules that make the cell membrane are like, and we talked about how they are set up, where there's the hydrophobic, which is water-fearing, and hydrophilic, which is water-loving parts of the molecule, and how those molecules form the cell membrane. And they are perfectly designed so that that in and of itself can allow for diffusion and osmosis to occur through the cell membrane and bring things in and out of the cell. However, there's more complexity to just that, and we've talked about this. It's not just diffusion and osmosis that allow things in and out of the cell, because what happens when you need to do something like send a protein you just folded out of the cell, and that protein is too big and cannot just diffuse through the cell membrane. So what it has is it has protein channels in the cell membrane. These proteins are called integral proteins, and some of these integral proteins pass all the way through the membrane, while others just hang on for dear life to the surface of the membrane. There's lots of different things that these integral proteins do for the cell. Some of these proteins act as border patrol officers, where molecules are regulated and some are allowed to come into the cell and others are kept out. And some proteins act as cargo ships that carry molecules from low concentration to high concentration by performing active transport, like we've studied. Some of the proteins act as foundation pillars for the cytoskeleton, helping the cell change its shape and be able to move around. And some proteins are embedded in the membrane and do the job of enzymes. There's still more proteins in that cell membrane that receive chemical messages and relay these messages into the cytoplasm, kind of like a telephone operator or a secretary. We call these proteins receptors, and many are actually hormones. All of these proteins, these integral proteins, are in that cell membrane. If evolution is true, then all these jobs of the proteins in or on the cell membrane just happen to accidentally begin doing the job necessary for life to happen for the cell. But how? How could the cell have even existed without these proteins long enough to have accidentally evolved each and every one of them? Take even one of these jobs away and the cell could not maintain life correctly. This happens with cystic fibrosis. Mutations in the protein channel cause devastating results that do not help the organism, but rather harm it drastically. And yet, we are told to believe accidental and unguided mutations brought about the beneficial changes needed to bring about life and form complex organisms like animals and humans. Basically, these integral proteins that we find on the cell membrane, they show that the cell itself is so much more complex than just a building block like a Lego. And they cry out the need for a designer. There had to be somebody behind it that thought about, how do I get things into the cell? How do I get things out of the cell? How do I signal the need the body has outside of that cell that's calling for a specific protein or a specific hormone to be developed? And I need that information to get into the cell so that the cell can begin to build that specific protein or hormone. Those are amazing feats that our cells do, and every single day, all the cells in your body are going through this kind of a process to keep you alive. It's not by chance. It's not by accident. You are not an accident of evolution. You're a purposeful creation created by a purposeful God with a purpose. All right, so we've got the cell membrane itself with the hydrophobic and the hydrophilic molecules that make up the cell membrane. Then you've got the integral proteins that are doing all sorts of jobs in that cell membrane. The next thing I want you to think about, there's cholesterol. Cholesterol is not bad. It's actually needed in every single cell of your body. Without the cholesterol, that cell membrane would just kind of goop out. It would fall apart. Without the cholesterol, it wouldn't have a fluidity so that the things could move around. See, everything in the cell membrane, as you'll see as you watch the video, if you haven't already, it shows you how everything floats around in the cell membrane. All of the integral proteins can float around, all of the cholesterol actually floats around, and many other things will float around inside of the cell membrane. The cholesterol is what keeps that integrity to the shape of the cell. Cholesterol keeps the phospholipid layer of the cell membrane from getting too hot or too cold, which is important because a cell will die if it gets too hot or it gets too cold. If it gets too cold, cholesterol acts like antifreeze for the cell, keeping it alive. If it gets too hot, it manages to keep it from melting and disintegrating. Without cholesterol, the cell would not be able to even keep a lipid bilayer together long enough to begin the process of life. So remember, the lipid bilayer is that hydrophobic and hydrophilic molecule that's stuck together in such a way to make that lipid bilayer. What I'm basically telling you is that without cholesterol, that phospholipid bilayer would not be able to stay together. So how could the first cell have just happened to find cholesterol to keep its cell membrane together with no guidance at all? Or is this like believing that just by chance I will find what I need at the grocery store when I go shopping? It just jumps into my cart without me knowing I needed it. That would be crazy. And so that cholesterol needed to be present at the same time as the cell membrane being created or coming together. So evolution wants you to say that just by chance that first cell came into existence, just popped in. And the thing is, with the cell membrane alone, we can't even just have that because we need the cholesterol too. We need the phospholipid bilayer. We need the integral proteins. Okay, the next thing that I want you to know about what we need in that cell membrane is what we call membrane carbohydrates. Membrane carbohydrates are like flags that identify the cell as belonging to the organism so the immune system won't attack the cell. You see, if I need to have a kidney, I can't just go get anybody's kidney and put it into my body. My immune system will attack any cell it does not recognize it as being my cell. So if I need an organ transplant, I have to find another person who has the same type of blood as I have. Otherwise, my immune system will attack that new organ. So blood cells are a great example of this. You've got a flag that says A, or a flag that says AB, or a flag that says B, or no flag at all, which is O. And those we call them blood types, and we're going to learn about that later in our class. Those flags actually are found in the cell membrane of blood cells. Okay, so to summarize really quick about the cell membrane, is that the cell membrane acts as a guard allowing things in and out of the cell. But it's bigger than that. It's more than that. It has to hold itself together. It's got to be able to send signals and all sorts of things too. The other thing I want you to understand, there are nerve cells in your body, and those nerve cells have to send signals as well from the outside world or the inside of you to your brain. And all of that information sharing and signals that are being given just cry out to the fact that you were created on purpose. Here's one of my very favorite. The white blood cell, do you know what its job is? Its job is to give its life in order to keep the body alive by digesting germs. That's its job. When I think about a white blood cell and what its job is, its job is to keep you alive at the expense of itself. Does it sound familiar? When Jesus died, he died on the cross, not for his own sins, but for your and my sins. He did something you could not do. He took care of the virus that we had, which is sin. And when Jesus died on the cross for our sins, he gave us the capability to have life. Just like the white blood cell inside of you, its job is to go out, find the germ, find the virus, and digest it, and then by digesting it, it lyses itself. It has to kill itself, going through the process of apoptosis, which is destruction of itself. So I love that picture that the white blood cell has to remind me again that all of creation points to its creator, and we can know the character of God. We can know who God is by just studying what He's given us right there in microbiology, your white blood cell. So what I wanted you to see today was the complexity of the cell membrane alone, that even if we just say, hey, that first single cell, it wasn't very complex, it was nothing more than a cell membrane and a compartment, and then it was able to evolve more complex things and more organelles over time, you still can't even get the cell membrane and the complexity of that cell membrane alone by chance. All of those pieces just to make up that fluid environment that's so absolutely essential for the viability of the cell could not have happened by chance. There was a designer that came up with every single piece that went into that cell membrane. Now later, on another day, we're going to look into the mitochondria and the Golgi apparatus and kind of look at what can we learn about that. What are their jobs? What do they do for the cell? And could those organelles have just popped into existence on their own by chance? See you next time.